CPM Calculus Chapter 2, number 87. So we're asked for each description, write a limit equation and sketch a possible function. So for A, we're given an approach statement. As x approaches 0, y approaches 9. Okay, so we can write that as the limit as x approaches 0, right, of y, the limit is equal to 9. Okay? And a graph of this will look like, so at x equals to 0 is right here. At y is equal to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 is right here. 10, 11, 12, right? So here's our x-axis and our y-axis. All we know about our function is that as x approaches 0, y approaches 9. Okay? So our graph can look like this, and anything on the left. As long as at 9 we're approaching, as long as at x equals to 0, we're approaching 9, we're good. Okay? So this is an example sketch, and this is the limit equation. The limit as x approaches 0 of y, so we're getting of y from there, equals to 9, we're getting the 9 there. Okay, so let's look at part B. So this one we're just given a description in words. As x gets closer to 3 on both sides, f of x becomes increasingly large. Okay, so that's saying as x gets closer to 3, that's the limit as x approaches 3 on both sides, so that means plus 3, or that means plus, right, equals the limit as x approaches 3 on the right and the left of f of x. As x approaches 3 on both sides, that's equal to increasingly large, so that's equal to positive infinity. Okay, so how we write the limit equation, again, since we're approaching 3 from the right and the left, we could simply say as x approaches 3 of f of x equals to infinity. Okay? And then let's sketch this. So we know that x equals to 3 is right here, and this is our x-axis, our y-axis. So f of x, how is f of x going to look? We know that as it approaches 3, it's getting increasingly large. So that's basically going to say that if we approach it from the left, we're going up, right? When we get to 3, it's going up to infinity as we're approaching 3 from the right. So we could go anything here, but once we get to 3, we're going to approach infinity again, right? So this is one possible example of f of x. Okay? So this is the limit equation, and here's a possible sketch. Okay. Finally, part C, we're asked, which of the limits from parts A and B exist? Explain your reasoning. Okay, so remember from part A, we got the limit as x approaches 0 of y is equal to 9. And from part B, we got the limit as x approaches 3 of f of x equals to infinity. Well, which one exists? And this is really the main point of, I believe, this section is exists, right? What does it mean to exist? And back, I think we looked at it at the beginning of the section, or the last section. We basically went over that if the limit as x approaches some value from the left, right, of our function equals to L, and the limit as x approaches some value from the right of our function equals to L, then the limit as x approaches to C, right, the left and the right hand limits, they mean that the limit exists and it equals to L. So one important asterisk, very important, is that this L has to be something that exists. So 9, yes, 9 exists. 9 exists, and So the limit as x approaches 0 of y equals to 9 exists. So this one definitely exists. So for part C, I can say part A exists. Part A, the limit exists. The limit of 9, right, exists. So we're happy with that. Now part B. So we know that the limit as x approaches to 3 of f of x equals to infinity. Well, what is infinity? Infinity, we know, goes up and up and up and up, you know, like in our graph, as x approached 3, it went up here and up here, right? And there's an asymptote at x equals to 3. But does infinity exist? Like, what is infinity? And in actuality, infinity is an idea and like kind of an abstract idea, but it does not exist. We cannot clearly define infinity, right? So there is no specific definition of infinity. It's just something that we're getting closer and closer to as we get bigger and bigger, okay? So that in actuality, infinity does not exist, okay? So only part A, the limit of 9 exists. In part B, the limit where the limit is infinity does not exist. So remember, when you're looking at things like this, L cannot be infinity, okay? Because infinity does not exist in the sense that it is clearly and well defined and definable. Okay, so this ends CPM Calculus Chapter 2, number 87.